Hello, math fans. All right, today what we're going to do is work on multiplying and dividing. We're going to do some integers, which is like super easy, but we're also going to work on rational expressions, which sounds very complicated, but it's not that complicated. Okay, so real quickly, just multiplying integers. I mean, this is all review here, guys, right? If you have a positive times a positive, or a negative times a negative, that is equal to a positive. Okay, very important. Okay, unlike addition and subtraction, right, that could be either one, but this is two of the same signs, positive, positive, negative, negative, gives you a positive answer. And then, of course, a positive times a negative, or negative times positive. It all depends on, it doesn't matter which one's which. One of them positive, one of them's negative, that's going to come out to be negative. All right? Pretty easy. So if I gave you something like this, 2 times 1 times negative 3 times negative 1 times negative 1. Okay, you should look at this and say, well, I've got 3 negatives, and if it's an odd amount of negatives, it's going to go back to negative. I mean, just kind of think about it, right? 2 times 1 is 2, times negative 3 is negative 6, times negative 1 is positive 6, times negative 1 is back to negative 6. What's equal to negative 6. So don't get thrown off by that. If it's an odd number of negatives, then it stays negative. And if it's an even number of negatives, then it goes to positive. Okay? Pretty straightforward, I think. And this is kind of an old, little silly thing. You probably played it when you were a little kid to your brother. Think you're so smart. It's if I said 2 times 8 times 1,000 times negative 1.2 billion times 0 times 7 times 105. Okay, and your brother's like, oh man, that's really complicated. And you're like, nah, the answer is 0. And then you sound like super smart, because as soon as you have a 0 in there, the whole thing goes to 0. All right, pretty easy. Division, the same thing. Okay, if it's a positive divided by a positive, or a negative divided by negative, it's equal to a positive. Okay, so don't get confused. It's like negative, and I guess I use division, and actually I want to point something out. This is a fraction. A fraction is really just division. Okay, so if I said something like, 6 over 2, that's the same thing as 6 divided by 2. I'm saying how many times can 2 go into 6? And that's equal to 3, and that's equal to 3. So division is the same thing as a fraction. Very, very important. Okay, so if you see negative 6 over negative 2, that's equal to 3. Okay, a negative over negative is a positive. Please don't look at it and go, oh, it's got to be a super negative because it's 2 negatives. Okay, there's no such thing as a super negative. So negative over negative is always a positive. Also, even with fractions, you usually don't see a fraction written this way. Okay, you don't see 1 over negative 6. You don't even say that. What do you always say? You always say negative 1/6. So put the negative on top. Negative 1/6. That's the way it should look. This is also acceptable to put the negative in the front like that. But don't put the negative on the bottom because you never say it that way. You don't say 1 negative 6. Okay? And you got to sound smart here in the world. All right? So I could give it to you as a fraction like that. I could also, with a fraction, or I could use the division sign. I actually don't see the division sign too much, but it is the same thing as a fraction. Okay, so negative 6 divided by negative 2, of course, is positive 3. All right, so that is positive over positive, negative over negative. If I have a positive over a negative, or a negative over positive, you guys know that comes out to be negative. It's just like multiplication. Okay, if one of them is positive, one's negative, turns out to be negative. So same thing, multiplication, division are the same, have the same idea. All right. Real quickly, 0 divided by 3. What is that? 0 divided by 3 is actually 0. Okay, but 3 divided by 0, that's undefined. If you type this in your calculator, you would get 0. If you type this in your calculator, you get an error. All right, we're going to talk about this later on when we get to slope. All right, but you never tell me if something gives you an error in your calculator, you don't tell me the answer is error. Okay, that is like really, really bad to give me. You need to give me either undefined or 0. Now, the reason 0 divided by 3 is 0 and 3 divided by 0 is undefined is for this reason. So let's just talk about that. So I'm going to write this as 0 over 3 and 3 over 0. This means this first one is what times 3. So what times 3 is 0? Well, doesn't 0 times 3 give you 0? That's why this one equals 0. If I look at the bottom one, what times 0 gives me 3? It's impossible, right? There's nothing times 0 that'll give you 3. 0, 3, doesn't matter. Anything times 0 is 0, so this doesn't work. That's why this was undefined. All right? Okay, so now let's use our knowledge of fractions with positive and negatives, and let's do some multiplication and division. All right, so let's kind of start out talking a little bit about a term called a rational number. And you might have heard that before, and I might have used that before, but a rational number sounds very complicated. But really what a rational number is, it's just another name for a fraction. So don't panic when you hear, you're like, rational number, oh my gosh, we're going to get into something really brutal. It's actually just a fraction, okay? So don't panic about that. All right, so let's do a nice little friendly problem here. 2/3, we're going to use the dot for multiplication, times 6 over 5. All right, what you need to do is you need to cross cancel. So cross cancel. And you're going to do this before you multiply the tops together and the bottoms together, okay? It's important. And basically, you should have learned this already back in junior high or middle school, okay? So this is really just a review, but we're going to go over just to make sure you guys are good to go. Okay, so what you're going to ask is, you can cancel anything from the top with anything from the bottom, but you can't go top and top or bottom bottom, okay? So for example, I have a 3 and a 6, so I can say 3 goes into 3 one times, 3 goes into 6 twice. Okay, I can't do anything with the 2's because they're both on top and there's nothing to cancel with the 5, so I multiply straight across then. So 2 times 2 is 4, 1 times 5 is 5, and my answer is 4/5. Okay, it's really pretty easy, but you got to remember cross cancel. Don't get that confused with cross multiply. That's something actually we're going to talk about later, but cross multiplying is when you're solving an equation and you have a fraction on either side. So don't cross multiply, it's cross cancel. Okay, now if I didn't cross cancel, what you'd do is you'd still multiply straight across, but it gets more difficult because let's just put my old problem back on here. 2/3 times 6/5. Okay, I would multiply straight across and I'd get 12. 2 times 6, 12, and 3 times 5, 15. And then I'd have to reduce that. Now that's actually kind of more difficult. And maybe you're saying, well, 12 over 15, that's not too bad. 3 goes into 12 4 times, 3 goes into 15 5 times, and I get 4/5. So I get the same answer. But it does get more difficult as the numbers get more complicated. So let's do another example here. 7/3 times 9 over 35. All right, so again, cross cancel. We got a 3 goes into 3 once, 3 goes into 9 3 times, 7 goes into 7 once, 7 goes into 35 5 times. So multiply. We can't do any more canceling. So 1 times 3 is 3, 1 times 5 is 5, and the answer is 3/5. All right, that's pretty easy. If I wouldn't have cross canceled, this is what would have happened. 7/3 times 9 35. You would have gotten 7 times 9 is 63, 3 times 35 is 105. And then you're trying to reduce 63 over 105. That's pretty tough. I don't really know what number goes into that. Well, I kind of do, but otherwise it really is pretty tough. And actually 21 goes into 63 3 times, and 21 goes into 105 5 times, and you get the same answer. But this is a brutal way to go. So that's brutal. This is a pretty sweet way. Okay? Very important. Also, just something that we learned before about the negatives and positives, just be careful, right? If I have one of them is negative, then your final answer is negative. If they're both negative, then it goes back to positive. So just kind of be careful of your signs also. Okay, don't say a negative times a negative is a super negative and it makes it, just ultra negative. That's really bad. Okay, it makes it a positive. All right. Let's do one more here. 6 over 21 times 7 over 20. All right, so remember I told you you can cancel anything from the top with anything from the bottom. And you know how I always did cross-canceling with the 21 and the 7 here? Well, I'm just going to do something different just to show you that it does work. I have the 6 and the 21. I can simplify that, right? 3 goes into 6 2 times. 3 goes into 21 7 times. Okay, now I've got a 7 and a 7. I can cross-cancel that. So 7 goes into 7 once, 7 goes into 7 once, and then I have the 2 and the 20. That's nice too. 2 goes into 2 once, 2 goes into 20 10 times. So my answer is 1/10. That's really easy when you cross-cancel. And once again, math fans, if I would have not cross-canceled, you would have gotten 42, 6 times 7, 42, and then 21 times 20. It's like, oh, it's a huge number, but it turns out to be 420. And then you can kind of simplify that one. It's not too bad, right? 42 goes into 42 once, 42 goes into 420 10 times, and you get the same answer. But this is not the way to go. All right? So cross-canceling is really key when you're doing multiplication. All right, let's talk about division now. 2/5 divided by 8 over 25. So this is what you do. That division sign, when you're doing division, it changes to multiplication. So it's 2/5, and then it's times, and you do the reciprocal, or take the reciprocal, okay, that's the mathematical term, and the non-mathematical term is really you flip the fraction. Okay, that's the non-mathematical term, but you flip the second fraction. That's important. Flip the second fraction. So 2/5 times 25 over 8. And then it's just like the old days, which is what I taught you 5 minutes ago, but you cross-cancel. So 2 goes into 2 once, 2 goes into 8 4 times, 5 goes into 5 once, 5 goes into 25 5 times. Multiply straight across, and you get 5/4. Now, some of you are also asking, do you leave it as 5/4 or do you put it as 1 1/4? So 5/4, this is an improper fraction. And if you write it as 1 1/4, right, 4 goes into 5 one times and you get 1 left over. This is a mixed fraction. And the question is, which one do I want it in? Well, I'll tell you, I want it as an improper. That's what I want. So, okay? So make sure you do that. And the reason I want it as an improper, it's good in math. You can leave things as an improper fraction when you're doing calculations and whatnot. The only time you don't leave it as an improper, the only time you leave it as a mixed fraction is when you have an application. All right? And the reason it's good to write it as a mixed fraction when you have an application is because, let's say, for example, an answer came out to be 8 1/2. And then, of course, as a improper fraction, it'd be 17 over 2. So these are equivalent. But let's say we ordered all these pizzas, and you guys munched on all the pizzas, and I had to give a report to the principal and tell the principal how many pizzas the class ate. And I went down to the principal and I said, principal, the class ate 17 halves of a pizza. The principal would be like, what? Are you kidding me? 17 halves? What the heck is that? And I'd be like, well, what do you mean? And you go, well, that doesn't really make sense, right? Doesn't it make sense to say, well, the class ate 8.5 pizzas? Oh, okay. They ate 8 pizzas and another half. That makes sense. So you want to use mixed fractions when you're talking about applications. But if I'm just using it as a calculation, 17 halves would have been perfect. Okay? So that's just kind of an important thing to realize. All right. Let's do another division problem here. Let's do 5/7 times, divided by, let's see, 15 over 35. All right, so I'm going to change it 5/7 times 35 over 15. Pretty easy. And then cross cancel, so 7 goes into 7 once, 7 goes into 35 5 times, 5 goes into 5 once, 5 goes into 15 3 times, and we have 5 thirds. Okay, again, 5 thirds, don't tell me 1 and 2 thirds. I want it as 5 thirds. So that's pretty mellow. Real quickly, what happens if I give you a problem like this? Let's see, 18 over 12 times 6. Okay, so what if I have a whole number and a fraction? I kind of mix it up together. Well, turn it into a fraction. That's the way to go. Even with division, I mean, whenever you're doing multiplication division, turn a whole number into a fraction because it's easy to multiply fractions together and divide fractions together. But it's difficult to say, well, gee, one's a fraction, one's a whole number. How do you deal with that? So turn everything into fraction, and then you're good to go. Because then I cross-cancel. 6 goes into 12 twice. 6 goes into 6 one time. And then I can even go top and bottom, right? 2 goes into 2 once. 2 goes into 18 9 times. So my answer is 9 over 1. Now, this is actually another point here that I want to make. You have 9 over 1. You always reduce your fraction. And I'll tell you, if you did cross-canceling correctly, you would have everything reduced perfectly. The only thing that really needs to be reduced a little bit more is if it's over 1. Otherwise, everything else is reduced. And if it's over 1, it's just that number. It's kind of like when we start out with a 6 right here. Right, we said 6, and that was 6 over 1, because we turn it into a fraction in order to make use of it and multiply it by the other fraction. But if a final answer comes out to be something over 1, just say the number. And think of it this way. If you go to the store or you're hanging out with friends and it's your birthday and somebody says, oh, how old are you today? And you go, oh, I'm 14 over 1. Okay, you're going to get beat up because they're going to think you're a big dork. Okay, you never say that. You always say, I'm 14, not 14 over 1. And I don't want to be responsible for you getting beaten up. Okay, so you need to tell me you are 14 years old, not 14 over 1. So always reduce anything over 1 to just that number. All right. The last thing I want to show you guys is if I give you a problem like this, 2.5 times 3 1/4. So these are two mixed fractions multiplied by each other. The main point here, guys, is you got to convert it. So convert to improper fractions. That's important. You got to convert it to an improper fraction because otherwise it just doesn't. It's not going to work out. Because I know you want to say 2 times 3 is 6 and 1/2 times 1/4. If you didn't convert it and you try to do it that way, it's wrong. So you would get 2 times 3 is 6, and 1/2 times 1/4 is 1/8, and you get 6 and 1/8. That's wrong, which I'll show you in a second. Okay, you got to convert it into improper fractions, which means, if you remember that, 2 times 2 is 4, plus 1 is 5. So it's 5 halves. 3 times 4 is 12, plus 1 is 13. So times 13 fourths. Now there's nothing to simplify, nothing to cross cancel, so you just have to multiply straight across. 5 times 13 is 65. 2 times 4 is 8. Now, just by knowing that there's nothing to cross cancel, that almost guarantees that this is, well, it does guarantee that there's nothing to simplify here. Okay, it's kind of nice. If you messed up and there was something to cross cancel, then you would be able to simplify that. Anyway, just to kind of compare this, 65 over 8, you know 64 over 8 is 8, so this is actually equal to 1 and 1/8. Now I told you didn't need to do that, but I wanted to do that just to compare. You have 8 and 1/8 and 6 and 1/8, and that's why this guy is wrong. You have to convert it into improper in order to multiply. Okay, so your answer really, this is what I'm looking for, is 65 over 8. Okay, so let's try one more here. 3 and 1/5 divided by 4 and 2/3. Okay, so let's turn into improper fractions. And 3 times 5 is 15, plus 1 is 16 over 5. Divided by 4 times 3 is 12, plus 2 is 14 over 3. Okay, so you have 16 over 5, and we're going to change that to multiplication, and you get 3 over 14. All right, and then we cross cancel. Now there's not much to do here, but there is something, and you're going to say 16 and 14. I know 2 goes into 16 8 times, 2 goes into 14 7 times. So 8 times 3 is 24, 5 times 7 is 35. And that's the answer to the problem, 24 over 35. Pretty sweet. Again, if you didn't cross-cancel first, you would have gotten, let's see, 6 times 3 is 48, and 5 times 14 is 70. And then you have to try and simplify 48 over 70. Okay, so that's not the way to go. This is definitely the way to go by cross-canceling. All right, so I hope you guys learned something with multiplication, division. Again, this should all be review, but it's really important you guys understand how to deal with fractions with multiplication, division, improper versus mixed, and negatives and positives. All right, that's it, math fans. Have a great day. Goodbye.